Welcome to Algebra 1, Semester 2, Unit 7. This is a unit on using exponents. As I've done in the past, if you just list this A, B, C, D clear down through, then you'll find that they match, and you can study them by putting them on flashcards, audio, whatever you prefer. So start doing that. You'll need to review them every night. From memory, I want you to also memorize these important facts. Square roots, the square root of 1, you're just asking yourself what times itself is equal to 1. So that would be 1, because 1 times 1 is 1. 2 times 2 is 4, so the square root of 4 is 2. The square root of 9 is 3. Please stop the video at this point, fill in the rest of the page, and then come back and check. Please pause and fill it in on your own and then check them. So there's the answers to all of those. And the answers there. They were in order on here, they will not be on the test. So please get them memorized. You're going to need those facts just to make life easier for you in algebra. Now cube roots. It means what times what times what. All of these whats being the same thing. Equal 1. Well, 1 is really unique because it's always 1. What multiplied by itself will equal 8, and that's 3 times that it's multiplied by itself. That would be 2. 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is 64. 5 times 5 is 25, and 5 quarters is 125. And 10 times 10 is 100, times 10 is 1,000. Please get those memorized. You will need them. Okay, how do we simplify expressions with exponents? Well, I'd like you to expand these, and then you'll see what the rule is, and you'll be able to more easily remember how to do this. So x to the third means x times x times x. X to the eighth means 8 of these. And then we have one more. If we count all these x's, we end up with 3 and 8 more and 1 more. Putting them all together, that is x to the 12th. Now, 4a to the 5th times 6a to the 7th. Realize that's not saying that 4 is happening 4 times, only the a. So it's 4 and 5 a's. 6 and 7 a's. And I would like to see you expand those out first. Now we have 4 times 6, and a, I won't make you write it again, but there's 5 there, there's 7 there. 5 plus 7 is 12. So we get 24a to the 12th. You're beginning to see when you're multiplying terms with the same base and exponents, we just add the exponent. That is a rule. A to the m times a to the n equals a to the m plus n. Okay, I didn't want you to memorize the rule, I want you to understand the rule so that you can apply it. So here, again, we expand it out. We have 3 y's, 2 z's, we have an x, we have 5 y's, and 2 more z's. Using commutative property, we can rearrange these. Realize there's a multiplication in between each one. So we have x should come first alphabetically, then we have 3 y's here, We have 1, 2, 3, 4, 5 y's there, so that would be y to the 8th. We have 2 z's and 2 more z's, so that's z to the 4th. Now this, again, I want you to expand. So you've got 3 to the 4th happening twice. We have 3 to the 4th and 3 to the 4th. Now, it's your choice whether you expand the second time. You certainly can. That's 3 times 3 times 3 times 3. And 3 times 3 times 3 times 3. But I'm not expecting you to multiply that out. I simply want to see that that's 8 3's altogether. This is x to the 5th, and it's happening twice. You must show that expansion. I will not give you full credit unless you show that expansion right there. So that means that we've got 5 x's, 5 more x's. That would be x to the 10th. We have a negative out in front, but then we have 3 x's. We know that writing it that way causes it to be equal to that as well, because the negative is not raised to the 3rd power. Even if it was, it would still come out negative. Okay, here we have 3x raised to the 4th, so that means 3x times 3x times 3x times 3x. Using commutative property, we would rearrange 3 times 3 times 3 times 3 and x to the 4th. That does mean 3 to the 4th, x to the 4th. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. X to the 4th. Please explain how you're getting the answer by showing me expansions. I don't want to see rules. It's too easy to get rules confused at this point until you get used to using them. Later on in algebra, I allow you to use the rules, but not yet. So now here we have this 5 times. So it's going to be a lot of expanding. We have x2, z3, x2, z3, x2, z3, x2, z3. Ignore the fact we just got in the way of that one. x2, z3. Now we have it 5 times. Rearrange this and realize you've got x2 occurring 5 times. You've got z to the 3 occurring 5 times. And I don't require the second expansion, but make sure that you're counting how many there really are. There's 2 there. That would be 4. That would be 6. That would be 8. And that would be 10. So x to the 10th. This would be 3, 6, 9, 12, 15. Z to the 15th. Now we come over here to do this one. That says a negative 5a to the 4th. We're going to go twice with that. Now rearrange so we have the numbers together to multiply them. And then we have the variables so that we can add their exponents. So negative 5 times negative 5 would be a positive 25. 4 a's and 4 more a's would be a to the 8th. Here, we can still expand when we have that squared. So we take 4a cubed b squared, multiply it again by itself, a cubed b squared, and then we take it times 3a. So in rewriting with commutative property, we put all the numbers to the front. That would be 4 times 4 times 3. Now we have a cubed times a cubed times a, and then we have b squared b squared. Yes, I want to see these expansions. 4 times 4 is 16. 16 times 3 is 48. And now count how many a's we have. We have 3 here, and 1 here. 3, 6, 7. A to the 7th. 2 b's there and 2 b's there. That would make 4 b's altogether. Count them up. Make sure that you know how many there are. Then the next one, we have the negative 4r to the 5th s, and it's being squared. So we have negative 4r to the 5th s multiplied by negative 4r to the 5th s times 2r s cubed. So bring all of our numbers out to the front. We have a negative 4 times negative 4 times 2. R to the 5th. R to the 5th. It's okay. And R. We have S times S times S cubed. Negative 4 times negative 4 would be a positive 16. Times 2 would be 32. Count up our r's. We have r to the 5th, r to the 5th. That's going to be 10 r's. Plus one more r would be r to the 11th. Here we have s to the 1st, and then to the 3rd. So we have 1, 2, and then 3 more would be s to the 5th. Next objective, it says, can you explain and fix mistakes made in the following problems? Well, they have y cubed raised to the 8th. So we take y cubed, and we do that 8 times. One, 2, 3, 4, 5, 6, 7, 8. We're going to end up with a lot more than 11 y's, aren't we? When you count these up, you're going to find that we have 24 y's. Okay? So they've made a mistake. They took the rules and they simply added 8 and 3 when they should have multiplied them. That's why I tell you I don't want you doing rules yet. Okay, and this one, let's see if we can spot this mistake. We have 2w to the 5th, 3, we'll put those in parentheses, w squared. Then we have a negative 3w squared, and that's raised 4 times. So we write that one 4 times. Okay? Now if we bring all of our numbers to the front, we have 2, 3, and then we have 4 of these negative 3's. I've got 4 of them. Now I can go with my w's. I have w to the 5th. Then I have 5 of the w squareds. Okay, up here, 2 times 3 is 6. 3 times 3, negative 3 times negative 3 would be a positive 9. Negative 3 times negative 3 would be a positive 9. So I've got 81, 9 times 9 times 6. That's going to be 486. There's a little mistake. Should be what that equals. It's 486 for the numbers. They had a negative 54. And then the w's, we have 5 here. 2 more would be 7. 2 more is 9. 2 more is 11. 2 more is 13. 2 more is 15. So a to the 15th. So we've got quite a bit of stuff going on there. Okay, so how do we simplify expressions? Again, expand. You've got 5 h's and you've got 2 h's. So show them. And you know from beginning algebra that if you have the same factor top and bottom, it can be reduced. So that leaves us with 3 h's on the top. I do want that expanded. Here, it does get a little bit ridiculous. There's 23 on the top, 17 on the bottom. This is one of those extreme cases where I'd allow you to simply subtract and say that that's -5 to the 23 minus 17, because that's what you did here. h5 minus 2 would also get you that result. So it's -5 to the 6th. Now I want one other additional change on this. Because it's raised to an even power, the negative is eliminated, because anytime we have a negative times a negative, it equals a positive. So when there's an even number of negatives, that becomes positive. Okay, here I would prefer expansion, so we have 3 m's, we have 5 more m's, and on the bottom we have 7. Now we cancel like terms, like factors I should say, top to bottom, and we end up with m to the first. You could just write m, you wouldn't have to write m to the first. Can you explain the difference between simplifying a product with the same base and simplifying a quotient with the same base? So I'm saying, what's the difference here between a to the 8th times a to the 3rd and a to the 8th divided by a to the 3rd? How do you work those out differently? Please be prepared in class to answer that question. So pause the video and answer it right now. Okay, now we're going to expand these. 5/9 squared would be 5/9 times 5/9. 5 times 5 is 25. 9 times 9 is 81. Don't be afraid that they're fractions. X, y, expanded 5 times, xy, 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 and xy. That's 5 x's over 5 y's. That's as much as we can simplify that. Next one, 3r cubed over r squared. Well, before we start expanding this to 4, we could look at this and say there's 2 r's down here and 3 r's up here. This is what I'm seeing. I could go ahead and cancel those and just have it as 3r. Now I raise that 3r 4 times. That would be 3 times 3 times 3 times 3, and then we've got 4 r's, r to the 4th. 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81, r to the 4th. Wow. Sorry. That 4 looked pretty bad. Okay. That's the end of the Unit 7 notes, 8.1 and 8.2. That's what those were, is 8.1 and 8.2. 8.1 and 8.2. Thank you very much.